Hello, my name is Collin, and I'm here with Sowmya to talk about our project, Georeferencing of Historical Imagery as a part of Data Science for the Common Good 2021. Aerial images of the Earth taken from drones, aircraft, or planetary satellites can provide rich insight into how lands and waterways change over time due to human development or naturally occurring processes and events. For such images to be fully exploited for analysis, they must be georeferenced. That is, each point in the image needs to be associated with a precise latitude and longitude point. These images depict the Boston Harbor in 2003 and 2019. We can observe here that over a short period of time, there are many changes that have occurred in the landscape, even in the short duration of 16 years. It is important to be able to analyze these changes to make critical decisions. That is possible only when these images are georeferenced. Analyzing land use has a wide range of applications in regional planning, creating maps of regions and studying historical changes from one point in time to another. Unfortunately, adding georeferencing information to an aerial image that is not already georeferenced is a time-consuming task that today can only be performed by trained human analysts. This manual process involves identifying points which have remained consistent between the two images, the aerial image and the modern satellite image. These points are called ground control points, or GCPs. GCPs are used to warp these images and propagate the geospatial information to the rest of the image. In this project, performed in partnership with UMass Libraries and the Department of Environmental Conservation, our challenge was to develop a fully automated approach to georeferencing aerial images by comparison to fully georeferenced commercial satellite imagery. But that's not all. We were given a corpus of nearly 5,000 aerial images over the Commonwealth of Massachusetts that were taken nearly 70 years ago. When we started, this was an unsolved problem with very little in the way of relevant prior art to build on. Advised by subject matter experts at industry partner Pixel Forensics, we experimented with a variety of image processing and computer vision algorithms. By the end of the summer, we delivered 2 image processing prototypes to our partners.
The first image processing prototype implements the task as originally defined, attempting to discover matching pairs of GCPs between an unreferenced input historical image, shown here on the left, and a fully georeferenced satellite image, shown here on the right. This system proved to be only partially successful because the computed GCPs were often inaccurate. The best algorithm we were able to implement produced GCP recommendations where the average distance between the identified points was more than 100 meters, which is generally too large for effective georeferencing without human review. Consider the example shown here. Let's focus on GCP recommendation illustrated by the diamond shape. Both the diamonds should ideally be placed on the road intersection. We can observe that in the 2019 image, the diamond is placed correctly on the road intersection of the two roads, but in the 1952 image, it is placed to the left and above. A human analyst could quickly inspect these points and adjust them to match the same location. In this workflow, the system-generated GCP recommendations are reviewed by an analyst who can accept, reject, or adjust them as needed. In this way, the image processing system accelerates the georeferencing activity, even though it does not entirely eliminate the need for human analysis. While working on the system just described, we had an unexpected success due to the fact that adjacent images in our corpus tend to overlap by up to 50%. We discovered that we could run our pipeline on pairs of overlapping images where one image was already georeferenced. Our pipeline then could recommend GCPs in the overlapping area and do so with an average accuracy of 30 meters. With that idea in mind, we modified our original image processing pipeline to instead operate on pairs of historical images with overlapping regions. This version uses a georeferenced historical image to discover matching GCPs in a second unreferenced but overlapping historical image. In the example depicted here, let's examine 3 pairs of GCPs recommended by our algorithm. Compare the regions within these 2 triangles. Both of them enclose the same road intersection. Same is the case with the circles and the squares. These automatically generated GCP pairs are so accurate that they can be used for georeferencing directly without human review. In conclusion, we set out to build an image processing system which could take historical images captured in the 1950s and then discover matching ground control points in modern satellite images that could be used to automatically georeference a historical image. Firstly, we designed an algorithm which recommends GCPs that are somewhat inaccurate and thus require human review. And second, we delivered an algorithm that has the potential to support fully automated georeferencing of overlapping images that are captured more closely in time. Going forward, our partners will use these pipelines to accelerate their efforts to fully georeference a historical image corpus and will gather data on how to use these pipelines and get the most value from them. Thank you for watching. To learn more about data science with common good, visit us on our website.